Look up at the sky. Every day the sun makes its journey. Every night the stars and moon dance above us. It seems so obvious, doesn't it? We stand still and everything revolves around us. This idea, Earth at the center of everything, reigned for millennia. It wasn't just a theory, it was the foundation of a worldview. But what if the most obvious thing in the world turned out to be the grandest cosmic illusion? Imagine the universe as a giant system of crystal spheres nested inside each other. At the very center, an unmoving Earth. Around it revolve spheres carrying the moon, the sun, the planets, and the distant stars. This is the geocentric model, perfected by the ancient Greek astronomer Ptolemy nearly 2,000 years ago. And it worked. It allowed predicting the positions of planets, solar, and lunar eclipses. But there was one problem: the planets. Unlike the sun and stars, they sometimes move strangely across the sky, stopping, going backward, making loops. This retrograde motion was a puzzle. To explain it, Ptolemy devised an ingenious but complex system: epicycles. Imagine a planet moving on a small circle whose center, in turn, moves along a large circle around the Earth, like a carousel on a carousel. This explained the loops, but the model became increasingly complicated. For 1,400 years, Ptolemy's system reigned supreme. It aligned with common sense and religious doctrines, but complexity grew. More and more epicycles were needed to make the model fit observations. Ptolemy's universe became cumbersome, like a clock with thousands of unnecessary gears. And then in the 16th century, the Polish astronomer Nicholas Copernicus dared to think revolutionarily. This is his book, De Revolutionibus Orbium Caelestium. In it, Copernicus proposed a heliocentric model of the universe, placing the sun at the center rather than the Earth. What if it's all backward? What if the sun is at the center, not the Earth? And what if Earth is just one of the planets orbiting it? This was an idea that changed everything. In Copernicus's heliocentric model, the retrograde motion of planets was explained much more simply as an optical illusion that occurs when the faster Earth overtakes a slower outer planet, like a car in the next lane. No complex epicycles needed. But Copernicus's idea didn't conquer the world immediately. Firstly, it contradicted millennia of tradition and obviousness. Secondly, his model with circular orbits still didn't perfectly match observations. More precise data was needed. And this data was collected by the Danish nobleman Tycho Brahe, the greatest observational astronomer of the pre-telescopic era. For years, he cataloged the positions of stars and planets with unprecedented accuracy. Although Brahe himself didn't accept heliocentrism, his data became a goldmine for his successor, Johannes Kepler. It was Kepler, analyzing Brahe's data, who took the next revolutionary step. He realized planets move not in circles, but in ellipses, and the sun is not at the center of the ellipse, but at one of its foci. His 3 laws of planetary motion finally accurately described the dance of the solar system. The mathematics of the cosmos became simple and elegant. The mathematics was convincing, but humanity needed proof for the eyes, and it was provided by the Italian Galileo Galilei, who pointed one of the first telescopes at the sky in the early 17th century. What he saw changed our understanding of the universe forever. He saw that the moon was not a perfect sphere, but had mountains and craters similar to Earth's. He saw that the Milky Way consisted of countless individual stars. He saw 4 moons orbiting Jupiter, proof that not everything revolves around Earth. But the most crucial evidence came from the phases of Venus. Galileo observed that Venus goes through a full cycle of phases, just like the moon, from a thin crescent to a full disk. This would be impossible in Ptolemy's model, but was perfectly explained if both Earth and Venus orbit the Sun. It was a visual knockout for geocentrism. However, these discoveries were dangerous. They contradicted not only ancient science, but also church dogmas. Galileo was forced to face the Inquisition and renounce his views to save his life. The revolution in thought proved no less turbulent than the revolution in the heavens. The ideas of Copernicus, Kepler, and Galileo explained how the planets move, but not why. Why do Earth and the other planets stay in their orbits around the Sun instead of flying off into space? The answer came at the end of the 17th century from Isaac Newton. His law of universal gravitation showed that the same force that makes an apple fall to Earth keeps the moon in orbit around Earth and the planets in orbit around the Sun. Gravity, it was the universal force governing the celestial dance. The heliocentric model received its final physical justification. Earth definitively lost its central status. We turned out to be inhabitants of a small planet orbiting one of billions of stars in a vast universe. It was a true cosmological revolution that changed our place in the world. This story isn't just about planets. It's a story about how we learn to see the world as it is, not as we wish it to be. It's a story about the power of observation, mathematics, and the courage to question even the most obvious things. From a cozy, understandable universe with Earth at its center, to the incomprehensible vastness of the cosmos, where our planet is just a tiny speck. This journey changed science, philosophy, and our very conception of ourselves. And who knows what other obvious truths await revision in the future.